This is 2.4, and we're going to actually start graphing today. You can do this warm-up on your own. Okay, we've been spending several days on this already, so just tell me what each of these things does. So like the negative in front reflects it over the x-axis. The 2 changes the amplitude to 2. Subtracting 3 inside moves it right 3. And then adding 5 up outside moves it up 5. Okay, so just list all of those things that you need for each of those. So write them out. So pause me, write out all the transformations from those graphs, and then we'll move on. So we're actually going to start sketching sine and cosine ourselves today. And based on the transformations, we're going to have to change them, but we're going to start just by doing normal sine and normal cosine. Okay? This method, so we're gonna always focus from 0 to 2 pi along the x-axis. I'm never gonna make you graph like back into the negatives or more than through 2 pi. I just want to see what's happening within one normal rotation. So we're always gonna label our graphs from 0 to 2 pi. When you take this quiz, you are going to be responsible for labeling the x-axis yourself, and it's worth a lot of points. Each question is worth a lot of points just to label the x-axis. So we need to make sure we know exactly where all of these numbers are coming from. Basically, all you have to do is count from 1 to 8 and put everything over 4. Okay? So you're going to do 1 through 8 all over 4. And always have a pi on top. And then you just have to reduce, okay? So this is 1 pi over 4. Well, 1/4 doesn't reduce, so you're done. Jump up here. This is 2 pi over 4. Well, 2/4 is 1/2, so then that's 1 pi over 2. It just reduces. Okay, that's it. Then we're at 3, so we're going to do 3 pi over 4, because we're just counting 1, 2, 3, 4, 5. So 3 over 4 doesn't change, so you're done. Jump up here. Now we're on 4 pi over 4. Well, 4 over 4 is 1, so it's just 1 pi. Then we're down here at 5. 5 pi over 4 doesn't reduce. So you're good. Back up here, 6 pi over 4. 6 over 4 is 3 over 2, so it's 3 pi over 2. 7 pi over 4 doesn't reduce. 8 pi over 4 does, because 8 divided by 4 is 2. Okay? So if you noticed, all of the even ones reduced, all of the odd ones did not. So the blue ones up at the top all had to be reduced. The pink ones at the bottom all stayed the same. But all you did was count 1, 2, 3, 4, 5, 6, 7, 8 pi over 4 and just reduced every other one. Okay? So practice doing that. 1, 2, 3, 4, 5, 6, 7, 8 pi over 4, reducing every other one. And then you're done. All right. Your y-axis is going to depend on your amplitude. So if there's not a number in front, then it's just going to be 1. But if there is a number in front, then that's most of the time what your y-axis is going to go to. So since our amplitude is 3, then your y-axis goes from -3 to a +3. So we just label this y-axis based on the amplitude or the number in front. Okay? I don't think I have this one again. Okay, so let's just practice with this one. So 3 sine of 2x. So our amplitude is 3, which means it's going to go all the way up to 3 and down to -3. So amplitude, these are the things we're going to have to pay close attention to, is going to be 3. There's a 2 inside the parentheses, which changes your frequency, if you remember. So your frequency is 2. Okay? You have to be patient, okay? These don't come quickly necessarily. I'm going to do normal sine in theta in pink, and then we can kind of visually see what's going to happen when we do the new one. Here's what we need to know about regular sine theta. Sine starts at 0. Okay, sine starts at 0. It crosses at pi, and it ends at 2 pi on the axis. So those are all the points where regular sine crosses the x-axis. Sine starts at 0 and goes up, so it has to top out directly in between those two x-intercepts, which is at pi over 2, which is 90 degrees, which makes sense because you know the highest point is at 90 degrees. The flip of that, the lowest point is at 270 degrees, which is 2 pi over 3. And then you just connect them into a smooth curve. That's regular sine, okay? Starts at 0, crosses at pi, ends at 2 pi. It starts and goes up, hits its amplitude at pi over 2, and hits its minimum at 3 pi over 2. That's one normal rotation of sine. Now, we're going to do the new one, okay, which has a higher amplitude and a higher frequency. So it's going to start at 0 as well. That part's not changing. Sine starts at 0 unless it gets shifted up or down. So we start at 0. It is going to top out at 3. So the highest point is going to be up at 3. However, it has to happen twice within 2 pi, not just once. So it has to do an entire normal rotation within pi, so half of this graph. So if you look at a normal rotation of sine, just like the pink one we have down there, it comes up, down, and stops. That's one rotation of sine. So this green graph is going to have to do that within pi, so it's got to get faster, which means it's going to cross at pi over 2 and end at regular pi, okay? Which means, so it has to top out at pi over 4 because it's getting faster. Everything is getting faster. And its amplitude's at 3, so it's going to top out up at 3 at pi over 4. And then bottom out, -3 at 3 pi over 4. And comes up, down, and stops. That's one rotation, and it had to happen within pi. And then the entire thing is just going to repeat on this other side. So it's going to cross in the same places. So halfway, it's going to end at the top, or on the axis. It's going to top out at 3, bottom out at -3, and it's just going to do the entire rotation one more time. And that's the new one. It got taller, and it got faster, okay? So those are the types of things we have to focus on. So your key points. So you're going to label your x and your y-axis accordingly. Your x-axis is always going to be labeled the same way. That's going to be the 1 through 8 pi over 4. The y-axis is based on your amplitude. You have your key points. So where it starts, ends, crosses your x-axis, and then your maximums and your minimums. Okay? This is important. You need to start your sine starts at 0. Your cosine starts at the amplitude. So they start in different places. And you are sketching, so it doesn't have to be perfect. But we want to make sure we can at least tell all those key points. All right, you can pause me and label the x-axis if it's not already labeled for you. Practice labeling it. And then we're going to do this one. There's nothing in front, which means my y-axis is my normal amplitude of 1 and -1. Okay, no amplitude changes. There is a frequency change because that's inside here. Oops. So my frequency is now 1/2, which means only half of sine is going to be happening instead of a whole rotation. Okay, I'm going to quickly do this. You don't have to do this, but regular sine, it's always nice to have something to compare it to. Okay, so regular sine starts at 0, crosses at pi, ends at 2 pi, tops out in the middle, and bottom in the middle. Okay, this is regular sine. The only thing that's going to be changing about my new orange graph is the frequency. That's the only number there that changed, which means that only half of pi, or half of sine, is going to be happening within 2 pi. If you look at normal sine, this is half of it. Okay, that first lump is half of sine. So we're going to take that and stretch it out. So it's going to start at 0. It's going to end at 2 pi, but the whole thing is getting stretched. So basically what's happening is this point is being transferred over here. It's being stretched, which means this top point has to be stretched over here. So it's topping out at pi instead of pi over 2. And then that's it. It's just going to be one lump. Bloop. If we were graphing more than just 2 pi, this would continue down here, and it would finally end over here at 2 pi. So it would keep going, but we are only at graphing through 2 pi, and only half of it was happening within that rotation. So now we're done. So the orange one is the actual graph. You do not have to have the pink one. Okay, you don't have to have all this stuff. Technically, that's what you're supposed to have. Okay, half of sine. 2 cosine. We have a number in front, which changes my amplitude. So 1, 2, -1, -2 on my y-axis because my amplitude changed. My amplitude is now 2. Be careful, this is cosine, so let's graph normal cosine first, and then we can translate it. Cosine starts at the amplitude, so cosine's going to start up at 1. It ends, they're going to start and end in the same place, so it's going to end up at 1. Cosine bottoms out in the middle, which means it crosses halfway in between each of those pieces. And then you can connect it. So cosine kind of looks like a bowl instead of a wave. Okay, one rotation of cosine just looks like a bowl. Okay, so that's normal cosine. The only thing that's changing on this one is the amplitude. Everything else about the frequency and period and all that stuff is the same. So we're just going to start up at 2, end up at 2, bottom out at 2, or -2. That's it. The rest of the key points stay the same, so they're going to both cross there. And it's still going to just start up at your amplitude, come down, bottom out, and end back up. It just got stretched up, but everything else stayed the same. Okay, so again, the purple one is the one you need. The pink one just kind of helps us see where we need to go with it. Okay, so that's it. That is 2 cosine. All right, 2 cosine 3. Want to make sure that we are knowing what normal cosine looks like first, and then going from there. Our amplitude, 2. Okay, down to -2 because of the number in front. Regular cosine starts at the amplitude, ends at the amplitude, bottoms out in the middle, out in the middle, and then crosses halfway in between each of those. This is normal cosine. All right, so this one's going to start up at 2 because my amplitude changed. Okay, so my amplitude is now 2. Do not lose sight of this. 3. So my frequency is now 3. That's a tough frequency. It's not going to be very pretty. You have to have this bowl happen 3 times within 2 pi. So this is going to be fast, okay? The biggest thing, it has to be 1.5 done by pi. So I'm going to be on the axis at pi, but I have to have a whole rotation and half of another one done by then. okay? It's always going to start and end in the same place, so it's going to start or end up at 2. We're just going to try to wing it from here because there's not a lot else I can figure out from there. So we're going to come down and up. That's 1 rotation. Halfway through another rotation. Ooh. Halfway through another rotation, so it's got to be down at the bottom at pi, not on the axis. So that's 1.5. Here's 2, and we need 1 more rotation down and ending up at 3. Okay, so there's not a lot we could have figured out from the start. This dot should have been down here though. So I should have had a dot at the bottom at pi. But other than that, that's 2 cosine of 3x. Okay, do your best. This is not going to be necessarily easy, but it's going to take some practice, so do your best and let me know what you need.